No intro, just starting off. I'm sick, so my quality is probably gonna be pretty bad. Okay, first one, where possible, use the substitution x equals u squared to solve for x. So um, for this, we have to plug in x equals u squared. The reason is because it'll make the overall equation easier to solve. You can do this by yourself without substituting anything, but it's gonna be pretty time consuming. So we just use u squared to make it a bit easier. So this is pretty self-explanatory. From here, you would, my bad. Okay, so from here, let me just change the color. You would just write down u square minus 4 to root u square equals minus 4. So obviously what we did is x equals u squared, so we just plugged it in there, right? And then from here, you can see, okay, this is probably not very clear. You can cut this and this out. This is what I'm talking about when it makes it easier. So u squared minus 4u equals minus 4. From here, this looks pretty familiar. This is a quadratic. So u squared minus 4u plus 4 equals 0. Now we can, start solving. So if you just factorize it, you can see that u is u minus 2. Or from here, I can just write down this u square minus 24 minus 24. See, I was reading the notes out wrong. 2u minus 2u plus 4 is equal to 0, right? So from here, you could write down u into u minus 2 minus 2 into u minus 2 equals 0, and this equals to u minus 2 square is equal to 0. Now from here you can just find the square root of both of these, so that this is just going to be equal to u minus 2 equals 0, which means that u is equal to 2. Then from there you can write down since u equals to 2, right? U square is 2 square, and 2 square is 4. And x is equal to u square. So x is equal to 4, which is a very simple solve. Okay, so next one is C. So this is pretty much the same thing, but a bit more harder. So from here you can do the same thing, just substitute. So u square minus 2u, u minus 15. So you realize I kind of skipped the step. I just put u here, u squared here, then cancel it out. So it's just u squared minus 2u minus 15, or equals 15, right? So this you can just write down again, u squared minus 2u minus 15 equals to 0, because you want to make this a quadratic, right? So from here, you can do the same thing, just factorize. So u square, you can get 5 and minus 5 and plus 3u minus 15 for this equals to 0. So this is, if you just take the common factors, so u minus 5. But I should probably write clear 5 and plus 3 over, or 3 into u minus 5 is equal to 0. So this is u plus 3, my bad, u plus 3 into u minus 5 equals to 0. Equals to 0. So that means u is either minus 3 or so u is either u1 is equal to minus 3, u2 is equal to 5, right? Now, from here is where it gets a bit different, right? So if you square these, right? Uh, square if you square these, and you're gonna get the right answer, right? That's where you're gonna get the solve for x. So this is gonna be 9 or 25, right? So okay, 9 or 25, that's what we got. But let's algebraically let's prove if it's 9 or 25 because it's one answer only. So let's plug in 9 here. Okay. So if you plug in 9, so it's 9 minus 2 into square root of 9 equals 15. So this is going to be equal to 9, and this is going to be equal to 2, and then this is going to be 9, right? Square root of 9 is 3. So what this is 2 times 3. So 2 times 3 is 6. Then 9 is going to be here. So 9 minus 6 is not equal to 15. 15. It's not, right? So we can say that 25 is the right answer. And okay, now let's put in 25. 25 here minus 2 into root of 25, which is 10. So 25 minus 10, which equals to 15. So this is the right answer. For all of these questions, you should plug these back in, or for anything in algebra, you should always plug it back in to check if it's right. So the next one. So the next one, question number 2. This is a bit trickier. So use x equals u cubed to solve x to the power of 2 over 3 plus 3x to the power of 1 over 3 equals 4. The handwriting isn't very clear. So this seems a bit, intimidating, but it's not really that scary. So in the end, what does this equal? We have to realize that this is equal to x squared. Let me change the color. X squared to the cube root plus 3x cube root, I should probably write this down, equals 4. So from here, this is a simplified version of this, right? It's just easier to work with this. And the reason why we have to use x is equal to u cube is because we want to make this quadratic. It's another tool that we can use. Later on during the maths O-levels exam, you're not going to be given the actual substitution value, right? You're going to have to make that up yourself because you have to, use your own logic to get this right. And in this question, they're kind enough to actually give us the substitution. So from here, you can say that x is equal to u cubed. So then that means that 3, let's write down cube root. So the cube root is u over 6 plus plus 3 plus 3 u cubed. Now you may be a bit confused. Okay, I understand how this is equal to u cubed, but why is this equal to u6? It's because there's a square here, right? So if you substitute this already, it's gonna be u cubed to the power of 2, which if you use the exponential rule, 3, it's gonna equal to u6, right? So from here, what we can do is we can, since right now this doesn't look very quadratic, but it is, you can cut these out. You can divide these, so this is equal to 2, and you can bring this to the other side. So what this equals is u squared plus 3u minus 4 equals 0. From here, you can factorize again. This is a very simple way to put it. So u squared plus 4u minus u minus 4 is equal to 0. From here, u plus 4. I realize that I have made u's and the 4's look very similar. So we u minus 4. Okay, this looks very similar. I should probably uh, change this up. So u into u minus 4 minus 1 with u. Oh, I meant to do plus here. Plus 4 is equal to 0. Therefore, I'm just skipping it one step here. U is either equal to plus 1, right, or minus 4. Now, uh, what is it? So, from here, uh, yeah, so from here you get u is equal to 1 or minus 4. And from that, you can conclude that since u cube is x, that means u is equal to either 1 or u is equal to minus 64. Now, you may think from the last thing you've done, hey, you have to plug these back in. So if you plug both these back in, it'll come up as, it'll be verified as the answer. So these are both valid answers. Just be careful, even though this doesn't really match. Like this matches, sometimes it doesn't match, so just be careful about that. Okay, so this is the next one. This looks the most intimidating out of all of them. So x is equal to u to the power of 3 over 2. So solve x to the power of 4 over 3 minus 10x to the power of 2 over 3 equals minus 9. So from here, what we can do is we can try to, not be scared by this. Don't be scared. Just plug it in normally. So u to the power of 3 over 2, right, to the power of 4 over 3, right? So then from there you can write minus 10 to the power of minus 10 into u over 3 by 2 to the power of 2 by 3 equals minus 9. Now from here, if you notice, there is something we can do. So this rule again, so x squared, x uh, y z. This is an exponential rule where we can say that x is equal to y z, right? So what we understand from here is we can multiply these. So u is equal to 3 over 2 by 4 over 3. You can simplify these. So ding, 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 ding. We get u squared, right? That's nice. Then 10. We can simplify this very well. This is just equal to u. And then, because this equals to 1, minus or plus 9 equals to 0, because we moved this. Now, this is much less intimidating to work with. So u squared minus 9u minus u plus 9 is equal to 0, right? So I should equal to 0. So then from here, u minus was it u minus or u into u minus 9 minus 1 over 1 into u minus 9 is equal to 0. Therefore, u is equal to minus 9 or plus 9, or this is u1, then u2 is equal to 1. So, what is it? I'm pretty sure I got all this right. So from here, what you can do is u is equal to 9, right? The first two. So this is 9 to the power of 3 over 2. Because you can see, use this 3 over 2. This is u, so 9 is equal to x, right? So then this is equal to, well, this is a square root of 9 to the power of 3. And that is equal to 27. This is 3. If you got this is 3, and then 3 to the power of 3 is 27. And then for u squared, this is just 1, 3 over 2, which is just 1, right? So that's for question 3. It looks intimidating, but we just have to simplify it pretty well. So this is the next one. For this question, 4b, they just ask, use the suitable substitution to solve for x. So from here, this is what I was talking about. So they won't give you the substitution anymore. Now we have to do it ourselves. Change my color, white. So here we can see that, hey, maybe using a square would be pretty helpful. So let's use the substitution x is equal to y squared. I'm going to use y instead of u here because y is just easier to use. It doesn't look like 4 all the time. So y squared minus 2 into y squared plus 1 is equal to 0. This is already in a quadratic form. Boom, boom. And this, so this is y squared minus 2y plus 1 is equal to 0. Right? So then this is just y squared minus y plus 1 is equal to 0. And then here on you can just you can conclude that y minus 1 square is equal to 0. I'm skipping a few steps, but you should still understand this. So y is equal to 1. So plug this back in. You should be getting the right answer. So if you square 1, so the thing is 1 square is equal to x. Therefore, x is equal to 1. You can verify this answer yourself. Now let me do C, because just in case you guys don't understand it very well. So this is a bit harder. X to the x into 2 over, or x to the power of 2 over 3 plus 3x to the power of 1 over 3 is equal to 10. So maybe I should not space it so much. 10. So this looks threatening, right? But we can kind of understand what we have to do. So using the substitution, x is equal to y cubed, we can say, hey, we can plug this back in. So y cubed 2 to the power of 3 plus 3 into y cubed 1 over 3 is equal to 10. Here we can simplify. So boop, boop. This is technically 3 over 1. So 3 over 1 into 2 over 3, which is equal to just 2. So then here you can cut this down. So this is just 3y. So again, y squared plus 3y is minus 10 is equal to 0. And here you can factorize it, of course. So y squared is plus 5, or 5y, minus 2y is equal, or minus 10 is equal to 0, right? Now from here, again, just do your normal thing. So y plus 5. I am slanting quite a lot. Hold on. Y plus 5 minus 2 to y plus 5 is equal to 0. Therefore, y is equal to minus 5, or y is equal to 2, right? I should probably rewrite this again. I am slanting quite a lot. Y is equal to minus 5, or y is equal to 2. So now plug these back in, and you will be getting x is equal to minus 125, or I should probably write the 8 down first. 8, and then x2 is equal to minus 125. And you can check for yourselves, these are both the right answer. So this and this are right if you plug them back into this equation. And you always should, because if you don't, you could probably mess something up. So then the last and final one. Okay, so from here we have question 5, the last algebraic question. Now this, we're gonna have to take this substitution for u to the power of 1 over 2, which this is also equal to, oh sorry, I keep on forgetting to do this, change the color. U is equal to square root of 2, right? Square root of u, right? So why do we have to do this? It's because right here we can see that we have a quartic, or yeah, a quartic equation. So the thing is, we want to make this into a squared equation, right? A quadratic equation, right? So that's why we'll use u to the power of 1 over 2. So from here, what can we do? This is simple, right? We are already given the substitution, so we can just plug this in. Uh, Hold on. Okay. So okay. From here, we can just put in u, what's it? U to the power 1 over 2, right? To the power 4, minus 5, or into u by 2 square plus 4 is equal to 0, right? Now, this square, what is it? 4. Oh yeah, this is u, by the way, so u here, oh, this is just a 1, so then this is equal to u squared minus 5u plus 4 is equal to 0. Now, from here, what you would do is you would write down, from here, you would write down, oh, sorry, again. Okay, so you write down u squared minus 4u minus u plus 4 is equal to 0. Equal better, equal to 0. And this is thus equal to u, u to u minus 4 minus, or say, plus 1, or, sorry, again, minus 1 over, or minus 1 into u minus 4. Okay, my brain is kind of lagging right now. You know, I have not got much sleep. It's 5:10 a.m. right now. So u is equal to 1, or u is equal to 4. Nice, right? Now let's plug this in, right? So then let's see. So square root of 1 or square root of 2. So from here, okay, by the way, I realized I did something wrong the entire time. Every time I said or, I meant and. So, yeah, replace this with and. That's a very critical difference, like a very big difference, or and and. So, you could say, sorry, oh, this is not, this is 4, right? You could say, okay, it's 1, or it's 2. It's 1 and 2, or 1 and 2. Again, 1 and 2. But if you're a bit keen, you can realize, hey, that is not the answer. What the answer is it's minus 1, or plus or minus 1, plus minus 2. Now, the reason why we're taking plus and minuses is because square root will always equal to plus or minus 1. But this is not always the case, so even the keen people may get this wrong. Sometimes if you plug this into this equation, it cannot be the right answer. So that's when you only take pluses or you only take minuses, right? Normally when we're doing when we are, this is a pretty big difference. In algebra, when we're taking any answers, it multiple answers are fine. So you can say plus 1 or minus 1. So x can equal plus 1 or minus 1. But when you're doing a regular operation, so let's say square root of 36, this will equal to plus 6. It will not equal to minus 6 because whenever you're doing any type of uh, any type of operation, it will always equal to only one answer. The principal root is plus 6, so we want to take plus 6. Now, that's a bit off topic here, but we should probably remember that for future cases. I don't know why I erased that, so 1 or plus minus 2. Now again, just plug in all 4 of these answers and see if they're the right ones, and they are. So now the next one I wanted to do, without wasting any time because I don't want to make this too long. I'll just explain what happened. So question 5b, it says, okay, take the same equation, but instead of it being minus, make it plus, right? So this is x to the power 4 plus 5x squared plus 4 equals to 0. Now do everything again, same way. What you end up with is u1 is equal to minus 1 and u2 is equal to minus 4. So plug this back in, you get x1 is equal to square root of minus 1, x2 is equal to square root of minus 4. So good. So you can see that these are both complex numbers, or they're not real numbers, right? So we can't use these numbers. So there are no real solutions to this equation. Now, for 5C, these are both the questions, and they're a bit more different, and I won't be doing them now. These are pretty long, but from what you've learned, you'll probably be able to do all these. So from here, what we've done for 4.3 is we did all the algebraic questions, which are question 1 to question 5, I believe. Yeah, question 5. This is the first part. So then from here on, all the graphical solutions will be from question 6 to question 8, or question 9, actually. So I would probably say this is the most important out of the entire thing, because question 6 and question 9 are much easier. Uh, but these are still important. Some popular, like some, not, what am I saying popular? What some important things to note is that for uh, hold on, let me write a few things. Uh, this. Always remember, in algebra, you're allowed to do this. So 36. Uh, my keyboard. Okay. Oh my god. The hell? What happened here? Acha. Whatever. So 36. This is gonna always equal to 6, right? But this is going to equal to plus or minus 6. In algebra, it's like this when you're doing any type of operation, single operation, it's always just going to be the principal root, which is plus 6. That is probably one of the most important things to note here. Second thing to note is that always check your answer. Plug them in all the time. For complex numbers, you can't plug them in. So sometimes for this minus 1, if you plug this in, it'll equal to root of minus 1, which is not possible. And then, yeah, that's pretty much it for the graphical questions for 4.3.